Hi, I'm Della from The Beauty of Play. If you don't know me, I write math curricula and other curricula. I host the beautyofplay.com website. I also host 2 subscriptions, one for all things homeschooling and one for math coaching and several other things. But today I'm going to share a math exercise that my daughter and I did with you, and I want to explain before I share that exercise what my goals were for this. So the very first goal for me was the logic and reasoning of math in this whole exercise. So the exercise that we're doing, the first question that I asked her is if we had 3 different ice cream flavors and we were able to purchase, buy, eat a three-tiered cone of ice cream, how many different combinations of those flavors could we have? And then I went on to ask, how would that change if we had 2 combinations? How would that change if we had 4 combinations? And then we are eventually looking for the formula. My second goal in this is to introduce the factorial expression. So for the vast majority of concepts, in the beginning they are not that challenging, and mathematicians in general are efficient. They don't like having to repeat themselves. So they come up with shortcut notations that make it easier for us to understand, that are built on lower concepts and notations. For instance, when we're looking at exponents, we get tired of writing times 2 times 2 times 2 times 2 times 2, and so instead of writing times 2, we do a little notation. We say 2 is our base, and this superscript up here to the right of the 2 is going to tell us how many times we're multiplying our base. Well, in the factorial, it's the same kind of thing. We get tired of saying 7 times 6 times 5 times 4 times 3 times 2, or if we're starting at 9, 9 times 8 times 7 times 6. So we use a little exclamation point to use a shorthand, a notation, so that we don't have to go through all that. Another aspect of what I'm looking for in this exercise is a look for patterns, a constant look for relationships and patterns. And so we are doing this relationship and pausing and then reflecting on what we just did. And then we're doing a little more of the exercise and pausing and doing a reflection on what we just did. And I called these because I've heard them called notice and wonder. Like, I notice, I wonder. That's what these reflections are for us. So when we're doing exercise, and not just this exercise, anytime we're learning a new concept, we are pausing at different intervals in that concept and making observations, which often leads to wonders. For instance, I notice that we're multiplying 2 here 5 different times, and I notice each time we go up a term, we're adding an additional 2, or whatever the observation is. Often these levels of observations will bring up a, I wonder what will happen in the next step. I wonder if this pattern continues throughout. I wonder if there's a shorter, more efficient way to do this, kind of thing. So those are some of the things that I'm looking for in this exercise. I hope you enjoy. This is our math today. This is the question that we're asking. We're doing combinations or permutations. And this is our selection of ice cream. So far, each that we've done, and we've only done 2 combinations of 3 flavors, combination of 2 flavors, and each combination has different flavors. So now we're getting ready to do 4 flavors, and we're naming this flavor here. And of course,
we're out of names.
We're out of names, but we're color coding. Okay, what are we gonna name this one?
This green fits pink perfectly.
It just was like we were out of colors and this had some green in it. So, you got some ideas?
Einstein's chocolate.
Oh, that sounds good.
Einstein.
I like that. I'll spell Einstein. Okay, so one of the things that we did the 3 combination first, and I did that purposefully if you want to talk about it. And we realized pretty early on that we needed some kind of system because it was really challenging to figure out all the combinations. So she decided that each flavor would be on the bottom, and then we would find the different combinations with that, which was helpful. So this is 2 blue, I think these are blueberry, and then 2 orange and 2 cotton candy combinations, with each one being on the bottom. So then we have 3 combinations, actually 2 times 3. So there we go. We had a total of 6 combinations for 3, and that is where we've gone so far, and I'll keep you updated. We're getting ready to explore 4 combinations of 4, and eventually we're going to look for a formula for this so we can see for the nth term what is our flavor combination, our combinations look like. Okay, we just got finished doing the 4 combinations. We continued with a similar system that we did for the 3s. We chose a bottom one, and then we chose the next color to see all the combinations we could do with that, and we found 6 for each one of those. So there were 6 with the mulberry being on the bottom, and 6 with the Einstein being on the bottom, 6 with the chocolate being on the bottom, and 6 with the, what is that, mulberry? Red ras being on the bottom. And so we're being systematic here, so we hit all the combinations, and now we're going to pause to do a notice and wonder and see what our observations are, and if we can have any patterns, so that we don't have to do the hard work here of continuing to find the combinations, but we'll know how many combinations are available for any number of flavors that we have. Okay, we did our notice and wonder, and what we notice is that each one is the term or the combination, like this one has 3 different combinations, times those combinations before it. So in this one we had 3 different colors, and we had 3 different 2s. So we could do this combination switching right there, happened here with blueberry at the bottom, here with orange at the bottom, and here with, was that red ras at the bottom? It might be another color, maybe cotton candy. And then we noticed when we did 4, that it was 4 times 6, which was 3 times 2 over here. So each time we can have the number of combination that we're working with times the number of combination that were possible on the last term. So when we looked at what those combinations, like what we were actually doing, we realized that we're multiplying from the term number, however many combinations that we have, all the way down to 1. So this one is 4 times 3 times 2. This one is 3 times 2. This one is 2. This one is 1. It works better going the opposite way this way. 2 times 1, right? 3 of these 2 combinations. 4 of each of these combinations. And then what I generally do after this is to say, especially making sure that we have the pattern, how would we find out what it would be for 5 combinations? how would we find out what it would be for 6 combinations? And I'm not looking for a calculation here. I'm looking for understanding how we would calculate. That's much more important to me than the calculation itself, because we have calculators for that, right? And so we did that for 5, 6, and 7, and 8, and 9. At 7, I gave her the shortcut notation so that we're not having to write all this out. It's the factorial. And then we talked about what it would be for n, any number. If we chose any number, what does that look like? We're multiplying n times 1 less than n, and then the next one is 2 less than n, and so forth, all the way down till we get to 1. Or for the shortcut, we can write n factorial. So these are permutations, if you didn't know, and they're really useful in probability, which we will eventually get to, but for us today, this was just a fun introduction because we're going to have a bit of a break, and I didn't want to go too deep into any new concept, and we're tired of practicing the other stuff, and so we did this today. I hope you enjoyed this exercise. If you are interested in this exercise and exercises like it, this is included in my multiplication and division math guide that you can find on my website, thebeautyofplay.com, and I have a whole series of math guides that you can use for your children to bring back in the play, the wonder, and the beauty of math. Thanks for joining me.